Okay, I'm live here with 52 weeks of Swift and episode 3. And the idea here is that I'm going to go through the material in Swift, the programming language guide, and just step by step go through each of the sections of the language guide. When I'm done with that, then I'll go into building applications, building mobile apps, building desktop apps, command line tools, microservices, you name it. But for today, we have the basic operators in Swift, and I'm going to go ahead and get into that. So if you want to follow along, you can just go to the official language guide. In fact, I'll just share my screen here, and that's probably a good way to start. If I go through here and I share my entire screen, you'll see where I am at. So basically, I have inside of here the Swift Programming Language Guide 5.5, and I also have a Playgrounds window open in Xcode. And if we start off with this basic operator here, we can just kind of go through this together. So an operator is a special symbol or phrase that you add that you use to check, change, or combine values. So this is really a foundational component for building things in programming, and you'll see these different operators for things you need to do logically. So in terms of the terminology, there are some things that are pretty cool about Swift compared to, let's say, Python. One of them is that they have unary, binary, or ternary operators. And in particular, with unary, this would just be things like, exclamation point B, right? That's a unary operator. Binary would be 2 plus 3. A ternary operator is something like A question mark B colon C. And so we can start off with just playing around with assignment operator. And, I guess if we just go through here, and I'm going to bring this to the left right here to give us a little bit more room. And I can just bring this over here. And you can see here we've got, some stuff I can play around with. I can say, let B equal to 10. And if I do a return here, that just assigns a immutable variable to B. If I do var A is equal to 5, this will make this a mutable variable. So I can change A, but I can't change B. And so what I could do is I can say A is equal to B. So that's kind of a cool little trick, right? That just demonstrates the fact that some things are changeable, some things are not. Now, the other thing that is pretty cool about Swift here, if we just keep going down the list, is this multiple assignments. And so the concept is similar in Python as well, which is you can actually unpack something from the right into the left. And so if we say here, we say, let X and Y go in, I can actually go through here and say 1 and 2. And this is going to unpack and assign X is equal to 1 and then Y is equal to 2. So if we go down here, we see that, and how it actually test this out. I could actually just say, print X and just double check what that is. And that should be 1, which it is. And if I go through here and I print Y, that should be 2, right? So it's a pretty straightforward concept, but actually also really powerful. Let's say you're dealing with, I don't know, some result from a database or a JSON payload or whatever, and you want to unpack, 2 pieces of it. This is a great way to do that. Now, one of the things that you can do is that in this case, they're mentioning that unlike assignment operators in C and Objective-C, the assignment operator in Swift itself doesn't return a value. So you can't say if X is equal to Y, etc. So let's go now to arithmetic operations. I think this is definitely a pretty good way to start with any language, is to use the arithmetic operations: addition, subtraction, multiplication, division. And in particular, one of the things that we can do is we can take a look at adding things together. And just like Python, it's almost identical. In fact, you just say 1 and 2, right? And it goes through, and we know that that will equal to 3. We see that on the right. If I want to do subtraction, same thing. It works the same way. You can do it with or without white space. I think it looks a lot more clear to have white space in between. Say 2 asterisk 3 would be 2 times 3. It goes through and gives us a result of 6. And I also could do, a decimal operation. So I do 10.0 and then slash 2.5. There we go. And this gives us a result. So that's one of the better ways to learn a language, is just to use these operators. Now, one thing you can do as well, that, and this again is something that's similar to what you can do in Python, is you can actually concatenate strings together, which is pretty cool. And so let's go ahead and read the documentation. It says, unlike arithmetic operators in C and Objective-C, the Swift arithmetic operators don't allow values to overflow by default. And so you can see here the addition operator is also supported for string concatenation. So if we go through here, we say hello plus world, and I return, it will go through and it'll print the hello world. So that is kind of cool. So, if you wanted to build out, like this space plus is space, I don't know, a phrase, or whatever you could just put, you could do the old PHP style string concatenation. You'll see a lot of people do. This is a phrase, right? And then it goes through and it builds it out into a sentence. So that is kind of a cool little thing to do. I would be curious what the performance characteristics are of that. Typically, the performance isn't great when you do string concatenation, but because there's a compiler with Swift, it's hard to know. The remainder operator as well is something that we know from our days of elementary math. And so if I want to go through and build that, I can actually do 9% for, and this will give us, what will this give us here? It looks like it will give us the result of 1. And so basically, this is going to round this off for us, right? Because if it's 8 divided by 4, it would be 2. So to determine the real answer, what we would need to do is tweak things a little bit. So we would say, basically, if we, this said the same method is applied when calculating a remainder for a negative value. And so if we go through here and we say minus 9% for, we can go through here and try this thing out, and we've got minus 1. So basically, the operator calculates the following occasion and returns the remainder as an output. Oh, I see. So it's actually giving us not the value, but the remainder itself, which is kind of an interesting concept when you think about it. It's slightly unintuitive that would give you the remainder, but that's one way you do it. So the next thing we're going to get into is unary operator here, minus operator. So if we say, let 3 is equal to 3, let's go ahead and try that out. And so that, again, this is creating an immutable variable. We can say let minus 3 is equal to minus 3. We'll go ahead and return that. And we say let plus 3 equal to minus 3. And what does that do? That it should give us back, it should, the ordinary minus operator is prepended directly before the value. It operates without any white space. So it's just really showing us how to do subtraction here. The plus operator as well, we can go ahead and do that. And so in this case, not that exciting actually, but let's go ahead and do this. Let's put this in, and then let's put in the let also minus into here, and then it's able to show that we were able to get that code to work. So the next thing we can do is compound assignment operators. So this is really common in a for loop, for example, is to basically accumulate something. And in this case, I'm going to go through here. I'm going to say var a is equal to 1. We say a plus equal to 2. So it just appends or adds that value inside of there. And so in this case, what did I screw up here? I didn't put a space. There we go. And said can there we go. So we've got a 3. So then if I did this, if I said a plus equal 2, you could do another a plus equal, and then we could do a 1. And so you could just keep basically appending to that same variable, because it is uh, a mutable variable, and this will actually just add to that value. So this would be something that would be very common in a for loop. Okay, next up we have the comparison operators, and this looks very similar to Python. In fact, I would say identical to Python, and that equals, you can see here, a equal is equal to b. That's a quality. So if you're testing, is a equal to b, and then doing some kind of, conditional statement, you could also say not equal. So if a exclamation equal b, if a is not equal to b, then do some other thing. If a is greater than, or a is less than, or greater than or equal to, or less than or equal to. So very, very similar to many languages, including Python, which is kind of the gold standard for logic. We can go ahead and try these things out. So if we want to go through here and play around with this, we could go through here and we could say 1 is equal 1. Yes, that's true. We could say, 2 is not equal to 1, right? That's true. We can say, is 2 greater than 1? We know that's true. If 1 is less than 2, is that true? And then we say, is 1 greater than or equal to 1? We know it is equal to, so it's true. Or 2 is less than or equal to 1. And we could even do, is 1 equal to 2? There we go. We finally got our first fall. So that's a fun way to play with these equality operators. Okay, so here. Let's get into a little bit more meaty details here with comparison operators. And so this would be a pretty good example. In fact, I'll just type this out so I'll get the practice. So if we say let name here, we just say let name equal to world right there. So we have a immutable variable. And then if I say if name is equal to world, then I would go through and I would build my, my conditional statement inside of here. So what we do is we put the brackets in here. The editor is pretty nice. It completes those brackets for me. I then go ahead and I say print, and I say hello world. There we go. And now I need to do the else section. So I need to open this up right here and do these brackets. There we go. And then it'll complete that for me. And what I will say is else, and then we'll put this bracket. I believe I'll just need to say else. Let's see, go through else. We need to change these brackets around here, which is this one will go here, and then this one will come here, and then we'll type in prints. I am sorry, and I'll do the formatting here with the string, and I'll say name. And I'm definitely learning a lesson here, which is that sorry, but I don't recognize you, which is that when it's a nested conditional, I should probably just paste it because it's harder to complete. So what am I missing here? I think I just am missing that this should work. Oh, extra at the top level here. So we've got this guy, extra if. Yeah, well, I'm going to be lazy and just say it's too much. There we go. Let's go ahead and put this in here. But basically, the whole point isn't that the brackets are bad. It's that we're using the name equality operator to do some kind of conditional statement with control flow. So similarly with this, you can compare two tuples, which is pretty cool actually. So let's go ahead and try this up. Next is if I go to these tuples here and I say one zebra is less than two apple, this would be true because one is less than two. So that is an interesting concept about how they're deciding to make something true. I guess you just look at the numerical values. So let's see how they do this. So they say you can compare two tuples if they have the same type and the same values. Tuples are compared from left to right, one value at a time until the comparison finds two values that aren't equal. So if the elements are equal, then the tuples themselves are equal. So I guess because it's looking to see that the tuple has a numerical type, it doesn't even compare the strings because it's not really it doesn't it's nonsensical to compare the string. Similarly, if we go through here, this would be equal, so this would be false, I believe. Let's see what it says. No, 3 is less. That doesn't make sense to me. Why would this apple is less than bird? Because true, because 3 is equal to 3 and apple is less than bird. I really don't know how it's getting this unless, for example, it is maybe using alphabetical, sorting to determine that, which is kind of interesting. Maybe it tells us, it says, doesn't matter that zebra is less because of comparison. However, the tuple's first elements. Yeah, that is interesting. I'm actually kind of curious about how that works. I'll have to later explore that around, but that is kind of a cool concept. Uh, in this case, we can run this one as well, blue, purple, and we can say that this is true, that -1 is obviously less. So the text here, how it's doing the comparison, I mean, I guess I could find this out because what I could do is let me just see if I can appease my curiosity here, which is I'm going to go to Apple and I'm going to verify that Apple is less than a bird. And I want to figure out why it's less than a bird. So it says true. So now what happens if I say, if we change this to Bapple, and what happens? And I change this, but let's change this to big, and we'll change this to what's past I would be, I don't know, BRB, and let's see what happens. True. Yeah, I don't understand how it's sorting this, but I'll have to look at that later. Okay, so ternary conditional operator is a special operator with three parts, which takes from the form of a question answer. It's a shortcut for evaluating one of two expressions based on whether the question is true or false. If the question is true, it evaluates answer 1 and returns its value. Otherwise, it returns answer 2. So it's really shorthand for a very annoying if-else statement, which in Swift is a little clumsy. I have to admit these brackets are not great for me, right? Because they're just hard to type out. And so, what we can do here with the ternary operator is make things a lot cleaner by, basically deciding an if-else statement. So if we go through here and we say, let content type equal to be 40, let's try that. Scroll this up a little bit. And we say, let has header equal true. Okay, that makes sense. And we say let row height equal content height plus hash header. And here's our ternary operator. And so what we're doing is basically we're saying that the row height should be 50 points taller than the content type if the row has a header, and 20 points taller if the row doesn't have a header. So yeah, it's kind of a cool little conditional statement here, and very logical. So you can see how this was 4 lines of code and the other one would be 9 lines of code. So yeah, I think the ternary operator is kind of a cool little trick. So now if we look at nil coalescing operator, it unwraps an optional A if it contains a value, or returns a default value B if A is nil. So that's definitely pretty cool too, that this is a very common thing in Python where you have to handle, null values. And it's neat that we've got a nice way to do this in Swift here. So we say A, if not nil, right? We can't find A in scope because there's no A. We haven't defined it yet. Let's go ahead and go here though, and let's go ahead and do a actual example of this, which would be, we go through here and we say let, let's go here and say let default color name. Let's go ahead and do that. There we go. And then we say var user defined color name. Here we go. And what we do is we say user defined color name is nil, because this is defaults to nil. And so what we're going to do is we're going to set a default, because we've set this to be nil, and in this case, this nil coalesce will set the default value instead. So again, that's a kind of a cool little trick there. And also we can go through here and we can run this in a similar thing as well, which if you assign a non-nil value to user-defined color name and perform the nil coalescing operator check again, the value wrapped inside is used instead of the default. Okay, cool. So what about range? This is definitely something that comes up a lot in programming. You use range a lot when you're dealing with for loops, right? That's really one of the most common use cases for ranges. And so the closed range operator defines a range that runs from A to B. All right, so this is kind of the simple thing that most languages are familiar with. So you basically say, run this thing between 1 and 5 times. Right. And so very, very, very intuitive here to build this out. In fact, why don't I just get some practice on it and type out the full expression, and maybe even go a little bit over here so I can do the whole thing at once. So we'll say, for index in 1 ... 5. I definitely like that syntax. It auto completes in the bracket for me, and then I just put in whatever thing I'm going to say. I would go through here and fill in my variable that's going to get formatted, right? Because index is the loop variable, so it's going to swap that one out, and then we say times 5 is, and then we can do some kind of operation inside of here, like which is pretty cool. So we could just say index 5, right? So we're just doing a kind of a classic thing you would do in a for loop here, and putting this in. There we go. Right, that looks pretty good. And I can see this thing appears to be syntactically correct. So we say print times 5 is index 5. What am I missing here? This looks correct, but just for speed, I'm going to paste this in and just, there we go. So I don't know if I made a mistake or not. Expected. Oh, well, I need a bracket here. There we go. And we'll go ahead and run that. And then we see the output. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. So pretty cool. So the half ranged operator defines a range that runs from A to B, but it doesn't include B. It's said to be half open because it contains its first value, but not its final value. As with the closed range operator, the value of A must not be greater than B. If the value of A is equal to B, then the resulting range will be empty. Half open ranges are particularly useful when you work with zero-based lists, such as an array, where it's useful to count up to, but not including the length of the list. Okay, that looks kind of a cool concept here. So in this case here, let's go ahead and build out a array, right? So an array in Swift is identical to Python. Essentially, you have these square brackets, We put some things in there. I define it as an immutable variable. I then can say count, and this will be names.count. So this gives me the number of elements in the array. So this would be similar in Python if you wanted to do, for example, len of names or something in Python. And so what I would do is I would say for I in 0, we do dot dot, and then we use that count, and then we put in again our brackets here. We say prints, and I'm just going to copy this because I can't be bothered to type it. It's just I'm too lazy. Let's bring this here and let's paste this in. There we go. Let's go ahead and run it, and there we go. Person is 1 is Anna, person 2 is Alex. Pretty common. A one-sided range. This is a closed range operator that has an alternative form for ranges that continue as far as possible in one direction. For example, a range that includes all the elements of an array from index 2 to the end of the array. In these cases, you can omit the value from one side of the range operator. This kind of range is called a one-sided range because the operator has a value on only one side. Okay, so we know we have this names thing up here. And so basically, I believe that this is a slicing type operation. And so if we go through here, we're just going to start our loop essentially. Because I pulled out names. There we go. So let's just leave names in here and the count in here. And I'm going to paste in this. We'll say for name and name. So basically slice it from this section and only do the last two, start at indexed 2, which again makes a lot of sense. And if I wanted to do the other side and it's basically operate on the other side of it, I would go through. So they're just calling this something different than what I'm used to in Python, which is slicing from the top or the bottom. Interesting concept for sure. I could definitely see how it could be easy to make mistakes with this type of iteration. Okay, so another thing you can do is one-sided ranges can be used in other contexts. So you can't iterate over a one-sided range that omits a first value because it isn't clear. You could iterate over a one-sided range that omits its final value. Okay, so let's go ahead and try that out. This looks kind of cool. So if we go through here and we say let range, I like that. That's kind of a cool concept. Makes it look pretty simple. And then we can say range dot contains, and then we just say 7. Like basically is 7 in our range? That's false because that's beyond 5. But 2, for example, is. That's pretty cool. So logical operators, we're just talking about this, not A and B, A or B. So this is very common in Bash, right? You do this all the time. In fact, any kind of a Docker file or Makefile, you have these kind of, or pipe operations, you have these kind of logical not and or. And so, let's go ahead and run this out. Let's take a look. So we've got let allowed entry false here. And we can say if if this is false, essentially, then print access denied. So we'll go through here and we'll say prints access denied. And let's go ahead and do this out. There we go, access denied. So pretty straightforward. What about an and condition? So the reason you would do the and operation or operator would be, you have two conditions, right? And you want both of these to be true at the same time, or else don't do this operation. So let's go ahead and run this in. This one looks pretty straightforward as well. We'll go through here and we build this out. We say let enter door code equal true. That looks good. We say let past retina scan false. And then if I say basically if both the enter door code, this is so similar to Bash, passed retina scan, I would go through here and I would put in my statement In this case, we'll say, hey, that's good, thank you. And the print statement is literally identical to Python, which is welcome if you're from the Python language. And then I can go through here. And then here's where I don't like this part of Swift, which is it's just really annoying, these else statements, because they're just really hard to get syntactically built. But I guess I'm getting the hang of things here. So you do the else here on a block. And then inside of this is where I put my logic, and I'll say, get out of here. Okay, let's go ahead and run this, and we can say, get out of here. So in this case, if enter door and passcode is true, print welcome. In this case, though, because one of them is false, we're going to say get out of here. Now, what about the logical or operator? And the reason for this is to basically, count on one of the things being false in order to do some kind of operation. So it's definitely an interesting concept to use or. It isn't that common that it happens, but it can be really clever to do this. So if we say has door key is equal to false, and then we say let's just, if they're big things, I'm going to just paste them in to be lazy. We'll say let's nose override password true, and then I'll say if has door key or nose override password, either one, then print welcome. And then we again have our friend here, the else, which is wacky to me, the way it's formatted. But we go and we do our else print access denied. Access denied. There we go. So we'll go ahead and do shift return. And we see that it says welcome because in this case, one of them was true. Basically, all that had to happen was just one of these is true. And so because one of them was true, we were able to be successful. If I change this to false, neither would be true. And so the or would not work. And there we go. If both are true, it'll also work, right? Because the or will allow us to just do either one, right? So either one potentially should work here if or is true. Not sure why that is not. There we go. Welcome. Yeah, that looks like that works. Okay, so combining logical operators, you can combine multiple operators to create a longer compound expression. So this is very common as well. So if you're building some kind of logic for some system, maybe you're building a scan reader for a mobile app, you would go through here and basically say, hey, if this thing and this thing are happening, then go ahead and do this logic. There's also explicit parentheses. Sometimes it's useful to include these just to make things more easy. So this is actually kind of helpful. I do agree with this. Like, for example, if you want to just put that together so people know that this is a statement, if this and this happen, or this other thing, go through and do it. So that definitely makes sense. So that's a good holding pattern for today. I'm going to stop sharing my screen. Yeah, so what we covered today was operators. There's a couple things I'm still fuzzy on. And so I'll go through here and play around with them a little bit more, like especially the string. I don't know why one value is evaluating to be equal or greater than another. I'll have to figure that one out. But I also like some of these other operators and some of the ways that the for loops are generated. the ranges are generated inside of Swift. So there's some cool things I learned today. And then next week, I'm going to cover strings and characters. Okay, well, thank you again if anybody was following along, and I'll see you next week.